A single rocket booster has now launched and landed more than 25 times, and what that one engineering achievement has done to the economics of reaching space is something the entire aerospace industry spent decades insisting was physically impossible. Before SpaceX changed the equation, every rocket ever built operated on a simple and brutally expensive assumption. You use it once, and you throw it away. The booster that carries a satellite or spacecraft into orbit burns its fuel, separates, falls back through the atmosphere, and hits the ocean. Gone. Every flight required a brand new rocket built from scratch. The manufacturing cost, the labor, the materials, the testing, all of it written off after a single use. It was the equivalent of buying a commercial aircraft, flying it once from New York to London, and then pushing it into the sea. That assumption shaped the entire cost structure of the space industry for 60 years. Launch prices stayed high. Access to orbit stayed limited. Only governments and the wealthiest corporations could afford to operate in space regularly. SpaceX broke that assumption permanently with the Falcon 9. The Falcon 9 first-stage booster is the component that changed everything. It stands approximately 42.6 meters tall, is powered by 9 Merlin 1D engines, and carries the majority of the engineering complexity and manufacturing cost of the entire vehicle. Recovering it instead of discarding it was the central engineering challenge SpaceX spent years solving, and on December 21, 2015, Falcon 9 booster B-1019 became the first orbital rocket booster in history to successfully return to its launch site and land vertically under its own power. That landing changed spaceflight permanently. Since that moment, SpaceX has refined the landing process into something that now looks almost routine, though the engineering precision required to execute it is anything but. After stage separation, the booster performs a boost back burn to reverse its trajectory, deploys 4 titanium grid fins for aerodynamic steering during descent through the atmosphere, reignites its engines for an entry burn to manage heating, and executes a final landing burn that slows it from hypersonic speeds to a near-zero velocity touchdown, either on land at a designated landing zone or on one of SpaceX's autonomous drone ships positioned in the ocean downrange from the launch site. The numbers that have accumulated since 2015 tell the real story of what this technology has delivered. As of mid-2025, SpaceX has successfully landed Falcon 9 boosters over 300 times. Individual boosters have now been reflown more than 25 times on separate missions. Booster B-1058, one of the most flown in the fleet, has carried Crew Dragon astronaut missions, Starlink deployments, and commercial satellite payloads, all on the same physical hardware, refurbished and relaunched repeatedly. The economic transformation this enables is measurable. A new Falcon 9 first stage costs approximately $30 to $35 million to manufacture. Refurbishment between flights costs a fraction of that. When a booster flies 20 or more times, the amortized cost per flight of that hardware drops dramatically, and SpaceX passes enough of that saving through to offer a complete Falcon 9 launch at approximately $67 million, significantly undercutting every major competitor operating expendable rockets. For context, the United Launch Alliance's Vulcan Centaur rocket, America's other primary heavy launch provider, operates as an expendable vehicle with launch prices reported in the range of $100 million and above per mission. Europe's Ariane 6 rocket, which finally began operational launches in 2024 after years of delays, is also expendable. Neither can currently match the per-launch economics that Falcon 9 reusability has established as the new baseline. The downstream effects of cheaper launch costs are reshaping every sector connected to space. Satellite internet became commercially viable at scale because launch costs fell. Small satellite companies that could never have afforded dedicated launches in the expendable era now regularly manifest payloads on Falcon 9 rideshare missions for as little as $6,000 per kilogram to sun-synchronous orbit. Scientific missions that previously waited decades for budget approval are finding pathways to orbit at costs that make them fundable. NASA's economics have shifted too. The agency now routinely contracts SpaceX for crew and cargo missions to the International Space Station at costs that independent analyses have shown are significantly lower than what it would cost to develop equivalent government-owned systems. The Commercial Crew Program contract with SpaceX for crewed Dragon missions has delivered astronaut transportation to the ISS at a small fraction of what NASA paid Russia per seat on Soyuz, which peaked at approximately $90 million per astronaut per flight. What makes the reusable booster story most remarkable is not just the technical achievement, it is the speed at which the industry has been forced to respond. Blue Origin is developing the reusable New Glenn rocket. Rocket Lab is developing reusability for its Neutron vehicle. Rocket Lab has already demonstrated booster recovery from its smaller Electron rocket. The entire global launch industry has been restructured around a reality that SpaceX proved in 2015 and has been refining with every flight since. The rocket that flies today may have already carried satellites, astronauts, and national security payloads on a dozen previous missions. It will be inspected, refurbished, and launched again. And again. The throwaway era of rocketry is over, and the booster that proved it possible is still flying. So here is what I genuinely want to know from you in the comments. When a single rocket booster can fly 25 times or more, at what point does the cost of reaching orbit drop low enough that space stops being something only governments and billionaires can access, and starts becoming something that changes ordinary life on the ground? Follow this page right now if you want to keep tracking the engineering breakthroughs that are quietly rewriting the rules of what humanity can do, because this story is far from finished.